Hello class, in this video I'll be showing you how to find the absolute extrema of a function. Let's begin. Find all absolute extrema of the function g of x on the closed interval 0 to 5. And before I begin, we're going to find the domain. And if you take a look at g of x, this is a rational function with an x plus 3 in the denominator, which means if x is equal to negative 3, you're going to have a 0 in the denominator, and your function is undefined. So the domain of g of x is all real numbers except x is equal to negative 3. In set notation, that would be x such that x is real and x doesn't equal negative 3. Next, we need to ask ourselves, is g of x continuous? In order for g of x to have absolute extrema, g of x must be continuous on this closed interval. And I'm going to answer that with a yes. The only value of x where g is not continuous is at x is equal to negative 3. Since negative 3 is not in the interval, g of x is continuous on the interval 0 to 5. Okay, so now that g of x is continuous on the closed interval, we can go ahead and find the absolute extrema. And we need to do that by taking the derivative of g of x. And since g of x is a rational function, we're going to apply the quotient rule. So it's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all divided by the denominator squared. If we simplify the derivative, we get this. And to find where the derivative is equal to 0, we're going to set the numerator equal to 0. So 0 is equal to, and I change all the x's to c's to represent possible critical numbers. And this trinomial factors as c plus 7, c minus 1. So we have c is equal to negative 7, and c is equal to 1. Now, we need to ask ourselves, where is the derivative undefined? G prime of x is undefined when x is equal to negative 3. However, g of negative 3 is also undefined. So x is equal to negative 3 is not a critical number. So we have two potential critical numbers here. We need to figure out if one or both or none lie in the interval 0 to 5. So let's take a look at -7. I don't think -7 lies in the interval 0 to 5, so we're going to ignore the critical number -7, and we are only going to use the critical number x is equal to 1, because 1 is in the interval 0 to 5. Okay, so now that we have the critical number, we're going to evaluate this function at the endpoints, 0 and 5, and we're going to evaluate this function at the critical number 1. And to do that, we're going to use Decimus. And I already have the function typed into Decimus. We're just going to evaluate it now at the two endpoints and at the critical number. So there are the three output values. Okay, so it looks like there is an absolute maximum at x is equal to 5. So there is an absolute maximum at x is equal to 5. The value is 2. There is an absolute minimum at x is equal to 1. The value is 0. And we have found the location and the value of our two extrema.